Hello students, let us continue the session on arithmetic progression. Here we have exercise 5.4. It is an optional exercise, means which will not be asked in the examination. However, we will see what sort of questions are there in this exercise. Let's start with the first question. Which term of the AP 121, 117, 113 and so on is the first negative term? They have given the hint. Hint is find n for an less than 0. Why an should be considered less than 0? The reason is it's a negative number. So we have to consider less than 0. Here a value is 121. The common difference is the second term minus the first term. It will be negative 4. If you consider an to be the first negative term, so let me consider let an be the first negative term of this AP, of this arithmetic progression. If I consider an as a negative term, an will be less than 0. We have learned the formula a plus n minus 1 into d for an. So we will substitute a value as 121 plus n minus 1 time of negative 4 less than 0. We have to solve this inequality. So 121 negative 4n plus 4 less than 0. This implies 125 is less than 4n, or else n is greater than 125 by 4. The approximate value is 32 because we get 31.25. Therefore, n value is approximately equal to 32. The next number I have to consider. So I can conclude, hence 32nd term of AP 121, 117, 113 and so on is its first negative term. Let us look at the second question. The sum of third and seventh term of AP is 6 and their product is 8. Find the sum of first 16 terms of AP. Here there is no information about the arithmetic progression. So let me consider, let the first term be A and the common difference be D. They are given sum of the third and the seventh term. So A3 is third term plus A7 is the seventh term. Sum of these two will be 6. Let me substitute the general rule. A plus 2D is a third term plus A plus 6D is the seventh term, which is equal to 6. So 2A plus 8D equal to 6. I can take 2 common, so A plus 4D will be equal to 3. I have divided. Let me consider the other condition. The other condition given is the product of these two terms, A3 into A7 is 8. Let me once again substitute. It is A plus 2D multiplied to A plus 6D equal to 8. Look at this equation 1. So from equation 1 we have A value equal to 3 minus 4D, so that I can substitute where A is there as 3 minus 4D. So 3 minus 4D plus 2D multiplied to 3 minus 4D plus 6D will be equal to 8. On further simplification, we will be getting 3 minus 2D multiplied to 3 plus 2D equal to 8. Now look at this, it is like a plus b into a minus b, so a square minus b square identity can be used, so it becomes 9 minus 4 times of d square equal to 8. With this I can get negative 4d square as 8 minus 9, which will be negative 1, so d square will be 1 upon 4. Minus and minus, they get cancelled, so this implies the value of d is plus or minus 1 by 2. If you consider the value of d to be positive 1 by 2, then a value will become 3 minus 4 times of 1 by 2, a will be 1, and the sum of 16 terms will be 16 by 2 times of 2a, which is 2 times of 1, plus n minus 1 is 15, multiplied to common difference is positive 1 by 2. Simplify this will be 8 times of 2 plus 15 by 2. We get the result as 76. You can check it out. And if you consider d value to be negative 1 by 2, then a will become 3 plus 2, which is 5. Now with this, I can find the sum of 16 terms as 16 upon 2 multiplied to 2 times of a, which is 5, plus 15 times of negative 1 by 2, which will be resulting to 20. Therefore, the sum of 16 terms of this AP is either 20 or 76, because there are two different common differences. Therefore, I can conclude, hence the sum of the 16 terms of this AP is 20 or 76. Let us take up question 3. A ladder has rungs 25 centimeter apart as shown in the figure 5.7. The rungs decrease uniformly in length from 45 centimeter at the bottom to 25 centimeter at the top. If the top and the bottom rungs are 2.5 meter apart, what is the length of the wood required for the rungs? The number of rungs will be 250 by 25 plus 1. This is the hint given. Let's see how to go about this question. According to the question here, 2.5 meter is the distance between the top and the bottom rungs, and the distance between two successive rungs is 25 centimeter. So the number of rungs will be 250 by 25 plus 1, which will be equal to 11. So let me mention here the distance between top and bottom rungs is 2.5 meter, and the distance between successive rungs is 25 centimeter. Therefore, the number of rungs is 250 divided by 25 plus 1, which will be 11. The length of the rungs is increasing from 25 centimeter to 45 centimeter in the form of arithmetic progression. So what will be the first term? The first term will be 25 and the last term will be A11. What is A11? A11 is A plus 10D. A value is 25 plus 10 times of the common difference is 25 centimeter. Sorry. 11th term is directly to be considered as 45. Sorry for that. A11 is 45 because they have given that uniformly in the length from 45 centimeter to 25 centimeter. So if you revert it, 25 centimeter will be the first and last will be 45 centimeter. Let me consider the common difference to be D. Let common difference be equal to D. Now let me take A11 equal to 45. Substitute, it will be A plus 10 times of D equal to 45. A value is 25 plus 10 times of D equal to 45. I can find the value of common difference. Common difference will be 20 by 10, nothing but 2. The length of wood required will be sum of 11 terms. So 11 by 2 times of 2A, which is 2 times of 25 plus 10 times of D. So it is 11 by 2 times of 50 plus 20. Therefore it is 11 times of 35, nothing but 385 centimeter. Hence 385 centimeter length of wood is required to make the rungs. Question number 4. The houses of a row are numbered consecutively from 1 to 49. Show that there is a value of x such that sum of the numbers of the houses preceding the house numbered x is equal to the sum of the numbers of the houses following it. Find the value of x. Here the first number is 41, next number is first number is 1, next number is 2, so on till 49. So from the information I can say that a value is 1 and the common difference is also 1. Now if I consider sum of n terms, it will be n by 2 times of 2a plus n minus 1 into d they have given the hint that we have to use x minus 1 equal to 49 minus sx. So sum of the number of houses preceding the house numbered x will be equal to the sum of the number of houses following it. It means sum of x minus 1 preceding will be equal to s49 minus sx. What will be x minus 1? It will be x minus 1 upon 2 multiplied to 2a plus x minus 1 times of d. I am just substituting n value as x minus 1. In the right hand side, I will be having 49 upon 2 times of 2a plus 49 minus 1 into d minus sx is x by 2 times of 2a plus x minus 1 into d. I have directly substituted using the formula. Now with the a value as 1 and d value as 1, let us further substitute it. We will be getting x minus 1 by 2 multiplied to 2 times of 1 plus x minus 1 is minus 2, x minus 2 times of, instead of d, substitute 1, which will be equal to 49 by 2 times 2a, which is 2 times of 1, plus 48 multiplied to 1 minus x by 2 times of 2 times of 1 plus x minus 1 into 1. So we get x minus 1 by 2 multiplied to, this will become 2 plus x minus 2 equal to 49 by 2 multiplied to 2 plus 48 minus x by 2 times of 2 plus x minus, this is 1, alright, x minus 1. So we'll be getting 2 and minus 2 getting cancelled. We'll be having x multiplied to x minus 1 divided by 2 equal to 49 by 2 times of 50 minus x into x plus 1 divided by 2. If you observe properly, on both left hand side and right hand side, we have got denominator 2. So I can take LCM and cancel this 2. What do I get? I'll be getting x times of x minus 1 equal to 49 multiplied to 50 minus x times of x plus 1. Let us simplify this. We'll be getting x square minus x equal to, the product is 2450 minus x square minus x. On both the side we have got negative x. I can cancel this out. So 2 times of x square will be equal to 2450. So x square will be equal to 1225. The value of x is 35. So the value of x is found. Fifth question, it's the last question of the exercise. A small terrace at a football ground comprises of 15 steps, each of which is 50-meter long. The length or the breadth here, 50-meter long, and built of solid concrete. Each step has a rise of 1/4 meter and a thread of ½ meter. Calculate the volume of the concrete required to build the terrace. Use the hint. Volume of the concrete is half into base into, it is LBH. The breadth is 50 meter, height is 1/4, and length is half. Let us solve this. Volume of concrete required to build first step will be 1/4 into 1/2 into 50, which is 25/4 meter cube. Volume of concrete required to build second step will be 2/4 multiplied to 1/2 multiplied to 50. We get it as 50/4 meter cube. On the similar note, for the third step, it will be 3/4 multiplied to 1/2 multiplied to 50. We get it as 75/4 meter cube. If you observe the pattern here, 25/4, 50/4, 75/4, each time there is an increase of 25/4 meter cube. So it forms an arithmetic progression with the first term as 25/4, and the common difference is also 25/4. Sum of 15 steps will be the total volume. So S15 will be 15/2 times of 2A, 2 times of 25/4, plus n minus 1 is 14 times of D value is also 25/4. So we get 15/2 multiplied to, this will become 25/2, plus this will be 175/2. On further simplification, we get 15/2 multiplied to 200/2, which will be, this will be 7.5, this will be 100. 100 times of 7.5 is 750 meter cube. Therefore, the total 750 meter cube volume of concrete is required to build the terrace. With this, we have completed the optional exercise, which is not important for the examination point of view. In the tomorrow's session, we shall discuss the questions from NCERT exemplar. Thank you.